about mammals. Mammals first appear around 230 million years ago, which is pretty early on in the life of reptiles. But we are a minor, unimportant group of species for over 100 million years. Nothing much happens. We are characterized by internal fertilization. That is, instead of fertilizing the egg outside the body, it's inside. We have fur, hair. We regulate temperature. We have temperature regulation, which is crucial for life. We have to keep it within very narrow limits. This allows for a more efficient physiology, because the temperature is the same throughout, more or less, with very narrow range variation. Our chemicals can adjust themselves to that temperature, and we are much more efficient. We have, I should also put on here, we have differentiated teeth. Look at the teeth of fish, amphibians, and reptiles. For those who have teeth, they look like this. And this we call homodont, or same tooth. It's the same shape. Different sizes in different places, but same tooth. The mammals, however, are heterodont. Remember that we talked about dental formula before? 2, 1, 2, 3 in humans. The original one being 3, 1, 4, 3. Now we have our teeth differentiated. This makes us more efficient eaters. We not only can grab food with our teeth and kind of chomp it around and then swallow it. Alligators, for instance, have to grab their prey and then thrash them around. The alligator will often roll around, and that will not only kill the prey but also kind of beat up the body. And then they can chomp off pieces and swallow pieces whole. Snakes will do the same thing. They'll swallow animals whole. Now, we have hot dog contests and so forth, so we sometimes do that too, but we don't have to. We can use our teeth as they were intended. We have teeth in front that will rip the food apart, or canines in back that will chomp it. Back of that, we have the premolars, or the bicuspids, and they cut the food up into smaller pieces. And finally, we have the molars in back, and they grind the food so that it's like putting it in an osterizer or a blender, and then we swallow it. Now, if we swallowed our food whole, big chunks of beef and stew and so forth, and whole potatoes or hard whole potatoes, our digestive juices would have to work to break that chunk up. But our teeth do the job for it. We grind up our food and swallow it, ideally. And of course, the word molar comes from the word for mill in Latin. In French, moulin as in moulin rouge, or molina as in Spanish. Molar is a grinder, and that was essentially the Old English term for it, grinders. They did it. Care of young, starting with nursing. Mammals provide milk for their young, and that is part of the care of the young and the protection of the young. Families are out over the sweatland, and African sweatland. It's a very specialized sweatland that produces milk instead of sweat. Mammals are, therefore, more of an animal that creates a small number of offspring and takes care of them. So you have a low number, high quality offspring. You go back to parasites, little parasites produce 1 million eggs a day. And then they just sort of spread them out and hope that some of them will be eaten. That's high output, low quality. We have a different strategy. And humans are one of the ones that have the lowest number of children with the highest amount of care. This is what an early mammal looked like about 230 million years ago. Well, dinosaurs, of course, were dominant for a long, long time. And then, once again, a big piece of space junk hit the Earth. This was a piece about 10 kilometers across, or 6 miles across. It hit at a town which is now known as Chicxulub in Yucatan. If you go to Yucatan and land in Merida and want to go to the coast, Progreso, Chicxulub is about halfway up. But that meteor hit and it was devastating, as you might guess. A piece of junk that big is going to be a pretty big hit on Earth. Well, a geologist by the name of Alvarez and his son, Alvarez, also a geologist, determined that if you look at that time zone at which the Chicxulub event occurred, if you look below that, dinosaurs existed. At the time that space junk hit, you have a layer of iridium across the Earth, everywhere. Iridium is a rare metal. It is used in jewelry. It is found primarily in meteors. Now, above that line, we find mammals. And above that line, we find that mammals not only exist, but animals really develop into a whole series of different lines.
Hey Lisa, turn one of those lights back on.
Back here is some ancestral mammal. Divides into 2 major groups. One is marsupials, which develop into things like kangaroos and the Australian mammals, and possums in South America. The possums have
better.
Come from South America out into Mexico and now the United States and up in Canada. And then the rest of the mammals are the so-called eutherian mammals. And I really have a hard time reading this, unfortunately. It's the only one I can find on the web. At any rate, we have a whole series of lines developing out of this basic core. Roger's book shows how whales develop out of land animals. They go into the water, their legs shrink until they just have little stubs inside their bodies. This is the primate line right here. This is right next to where tree shrews, golden moles, hedgehogs are on this side, and on this side, squirrels, rabbits, porcupines, etc. are other closest relatives, but not very close at all. At any rate, what happens is that the dinosaurs, which inhabited or which took up all of these ecological niches, it's like having a company with lots of different jobs, and all of a sudden, everybody is fired, and that opens up spaces for mammals or for other people to come in. In this case, it takes a while to develop, but they do develop out of this base right here into a whole series of different lines, which seem very distantly related, but nonetheless, that's it. And so by the time we get to the tertiary